Hey, good evening, everyone. Welcome to today's session. This week we're going to be looking at, we'll be doing essentially an overview of agentic AI protocols, and we're going to look at how these protocols would um, be leveraged to create interconnected agents that interact with each other, that can be integrated to handle um, tasks, to solve problems, and then there's agents that collaborate with each other. So as usual, we'll start today's class with we'll start by reviewing by having with a recap of what we covered last week. So who would volunteer to give us that recap? Yes, are you speaking? Your mic is unmuted, but I can't hear anything.
Can you hear me?
Sure, I can hear you now.
Okay, so I would like to give a recap on what we did on Tuesday because I haven't gotten time to revise what we did on Thursday. So if maybe Olaro and Drew could take this time to clear like his thoughts, and now whilst I give a recap on what we did on Tuesday, so that
You are the
we can.
professor, sir. You are the professor.
Okay. So I remember that last week Tuesday we spoke about LLM agents evaluation, and I would like to give a simple explanation about what it is. And basically, it is the process of we assessing autonomous AI in our workflow based on performance metrics, such as maybe the task and our completion. And I also learned that um, evaluating only the outcome can be misleading because an agent might give you a correct answer, but will use a whole lot of steps and like in getting it. Whilst maybe like we could just use maybe like two steps in getting that final answer, and like that like doesn't mean that like process is a good process because like there is a much simpler way of maybe like getting the answer. We also spoke about categories of AI agent failures, and we started to speak about planning and reasoning failure, and this occur when the agent thinking process break before we even start to make a specific action. So let's say the agent starts on a task and it slowly um, drifts to a topic which is not relevant to us, such as maybe over explaining instead of delivering the requested outcome. So, like that is the first category. The second one will have to be tool and execution failures. Um, this can happen when the agent chooses to use its available capabilities incorrectly. And maybe the agent is trying to get an API, but it's using an inappropriate maybe way of like getting that tool. So And let's say, so now let me move to the third one. The third one would be memory and states failures. And now this happens when an agent must track information over time and fails to be consistent with that like specific state that it was supposed to track. I think security and safety failures is also part of that because an agent can take real world actions. Security flaws can have a high stakes too as well. And we also spoke about the challenges. So I've spoken about the categories, and now we went ahead to speak about the challenges in AI evaluation. So the first would be the state problem. So like okay, so the first would be the state problem. So the state problem is actually about environment volatility. Let's say the agent's changing of making a test like non-producible. And the next one will be LLM as a judge. So we define the reasoning LLM as a judge. In this case, that would be, let's say the LLM will give us um, an inability to verify if a true output was actually correct. And I think that would be for that one. And we also proceeded speaking about
Sorry,
the
Kenneth. I think you're mixing um, um, failure causes of failures, or is it failure categories with evaluation?
okay. Or then
We talked
maybe
about
I will have
LLM as a
to.
judge when we were talking about evaluating AI agents.
Okay. So then maybe I have maybe like I didn't like structure and like my thoughts well. So I will go over and like go and like relearn what I am like complicating.
Okay, okay.
Yeah. And the agentic evaluation tiers. I also like
That
recall that we spoke
that's still
about.
evaluation.
Okay,
What
okay,
we
okay,
talked about okay. You're right.
okay,
You're right. We talked about evaluation last week, right? But when you're talking about failure, we hadn't gotten to LM as a judge. We talked about failure categories, including reasoning failures, action failures, and environment failures. And we talked about the different um, causes of these failures, including environment brittleness, infinite loops, and context drifts, and tool
okay,
use gap, I think. And we now looked at evaluation itself because the reason you evaluate is to be able to know when your model is failing and when it's meeting the um how will I say when it's meeting the required performance threshold. Performance in this case could also refer to safety and ethical and ethical AI transparency in the AI and LLM as a judge. We talked about it in the context of methods that you use in evaluating your AI agents or models, as the case may be. That's just the rejoin I want, the interjection I wanted to make.
Okay, so I might finally like speak about the agentic evaluation tiers. So like there's the components levels where, and there's the system level, and there's the trajectory level. So what happens at the component level? It's let's say, can you hear me?
Yes, I can hear you.
Oh, okay, so now what happens at the component level is we test for the parts in isolation. Like that's what happens at the component level. And the system level is we are basically testing for the interaction between probably between the brain and its like environment. And now the brain here will be the model, and the trajectory and my level will be the kind of testing that we are testing for the logic and the efficiency of the journey. Um, so like so far, like this is what I can recall, and I also like go back and like revise what I like messed up. So I like thank you for the opportunity to share what I recall. Thank you.
Okay, you're welcome. Lara, do you have something you'd like to add?
Okay, sir. Kenneth has actually said a lot, but let me just add a bit to it. You started by telling us, of course, the topic itself is AI agent evaluation. So you started by telling us four different AI, agentic AI evaluation metrics. That is a very four key points to note, or the aspect of measurement to evaluate if an agentic AI system is up to expectation or not. And the four of them are outcome metrics, as the task outcome metrics. The second is the process or trajectory metrics. The third is system efficiency metrics, and the fourth is reliability and safety metrics. The task outcome metrics is to measure if the agent is performing the task that it was given. That is, if it's doing that particular task without, in other words, we're interested in knowing the rate of success in the task given to it, if it's completed end to end without any failure and without requiring any human intervention, which is not a planned human in the loop. But if a system fails, definitely man or human being has to step in. And some other areas of measuring the outcome of the task given to the agentic system is the probability that the agent succeed at least one given attempt of the same task. Call it pass at K. I think that K may be a variable defined for the metrics. So that's the probability that the agent succeeds at least once given K attempts. Maybe for instance, if it's given 3 attempts, did it perform or did it meet the task? Did it perform the task within those 3 attempts? So, but then if other evaluation metrics is allowing 5, so maybe they will allow you to try like 5 attempts. Oh, and within that window of attempt, want to know maybe the task is performed to expectation. And then you told us about the progress rate, which measures what percentage of the sub goals were achieved before a failure. in a multi-step task. In other words, the task may be very large, but we want to know the extent of how far it went, what percentage of the goals were achieved before a failure. So that if we have two agentic systems and they both fail, we want to know how far one went before failure, how far it was able to go than the other. Then, for the sake of time, the second matrix is the progress and trajectory matrix. Here, based on trajectory, you want to know the efficiency of the agentic system as far as plan is concerned, as far as tool selection accuracy is concerned. In other words, as far as tool selection accuracy is concerned, want to know the percentage of the API tool calls that target the correct tools. In other words, a tool call might be made which is a wrong tool. So we want to know how much correct tool call were efficiently called, correctly called. And they want to know the trajectory efficiency, ratio of the optimal steps to actual steps taken. We want to know out of the steps taken, how many of them are correct optimally. Then plan adherence, you told us, being the third sub point under the metrics for trajectory. We want to compare the agent's plan against the actions that it performed. In other words, normally a reasoning system, a reasoning agent will first have a reflection at we think this is what I plan to do. So we want to benchmark or want to juxtapose the intended plan versus the executed plan. How much did the agent adhere to the initial plan of his action? In other words, I want to do this. After this, I'll do this. So listing 5 plans, they want to compare what step he took against those plans. Want to see how much that's part of the progress and trajectory metrics. And then context utilization being the last is a score that measures how effectively the agent uses his memory or RAG to make decisions. So we are interested in knowing how grounded the decision making of the agency system was. The third is the system efficiency matrix that you taught us. The system efficiency matrix here is talking about the the based on efficiency, how much token did this agent system consume per task? In other words, if you have two systems, one is taking too much, like a question I asked last week, a reflection I put in like we need to be more verbose. We need to be very detailed with our prompts. That so as to give good context to the agent to avoid hallucination. But you told me, you answered by saying that as much as we want to, we should consider cost in our decision. So at the same time, we want to know how our agent system is faring as far as token per task is concerned. Total number of input and output token consumed per resolution. And then latency involved is time taking in the iterative cycle of thinking, acting, and observing. We want to know how quick and how fast the system is. And I'm sure this may bear on the what's this? There is this particular loop in our maybe for the one that will have this routing function, for instance. So we need to really optimize our system such that there's not much time wasted, no latency as much as possible. And then the cost per success and the reasoning to action ratio. So this one is similar to the previous one, which was the one I mentioned before. And then the fourth, if I'm right, the fourth metric is the reliability and safety metrics. We want to know, is there, how much hallucination happen, or how often does it happen? How frequent are these in the agent? Whatever when the agent wants to invent tools and there's no grounding, maybe no access to some. How much is he able to give accurate answer? So we measure hallucination rates when data is not present in his environment. Want to see how frequent is hallucinating, the recovery rate, For instance, when there is a problem, there's an error. For instance, maybe transient error or persistent error, for instance. So, want to know percentage of times that the agent is able to recover successfully from an external error, maybe an API error or something. Want to know how does it crash? Is it able to reflect and correct itself? Then consistency, part of reliability and safety metrics. Want to see how divergent is the agent's part when it's given the same prompt multiple times. Is it deterministic? And I think this may depend on the temperature of the setting. I'm not sure. I'm just asking. And finally, guardrail evaluation rates. Guardrails are given to protect the system from misbehaving or from being misled. So we want to see how compliant the agency system is to these protocols given to it. How often does the agent attempt to access tools that it's not authorized to attempt? And does it generate content that is asked not to generate? So this about then finally you told us about the methods for evaluating agentic AI systems. You gave us three of them: deterministic evaluations, LLM as a judge, and then human in the loop. I hope I'll be able to. So I hope time is not too taking, sir. Hello,
Well,
sir.
it's a bit detailed, but it's fine.
Sir.
It's
So quickly
fine.
rush up. Yes, sir. So the three methods you give to us: one is deterministic evaluations. LLM as a judge, the second, while human in the loop is the third. And you told us the best practices for evaluating agents, and you want to know the helpfulness, how helpful is the agent action in achieving the user's intention. How concise is it? That is, how close the number of tool calls is it to the optimal execution part? As in, are they relevant tools that it's called? Then the third sub point is self-correction. How well was the agent able to fix its own error? And tool selection. Was there a cheaper or faster tool than the selected one? Talking about maybe cost optimization in this place. And then observation grounded. Did the agent ignore tool outputs? Like you taught us, when a tool output is in the state, ideally to return, and then the node will be able to assess what is the last message. Is there a tool call, or as the task ended, then it will go to the end. So we want to know maybe if there's a tool in the output or any other specified information in the output. Did they work on it? Did they ignore it or not? And then I think that's the. Then finally, you gave us the two more things. You gave us the benchmarks for evaluation agents. Like Kenneth said, we should not only depend on accuracy. We should go beyond accuracy, and we should assess tool use, the planning and completion of tasks in different domains, not just only one. Then, especially, we mentioned two examples: software engineering benchmark and then the Gen AI assistant benchmark. And finally, you gave us the evaluation-driven AI agentic development workflow. That is when we are concerned about evaluation, and that is what is driving the workflow. You mentioned the golden data set. You mentioned like if you could curate about 10 to 50 such data sets to create it to make the agent run. And then we run the agent against these data set scenarios. And I think this is like matching it with a perfect data set such that its evaluation um, is now is now tested on its own eventually to check its reasoning on a normal day apart from that set. That's the bit I can speak to, sir. Thank you, sir.
Okay, thank you very much, Olanwaju, and thank you, Kenneth, for the recap. So I guess we'll move on to what we have for today. So today we'll start by talking about the AI agent integration world. Um, it's not so easy to integrate AI agents because integrate them to work together or to integrate tools with them. For example, for every new tool, my apologies, please, baby's crying. For any new tool that you integrate, any custom integration that you make to your agent, or for any new tool you want to um, give your agent access to requires a custom integration typically. And that's like the N+1 problem. N+1 is a known and proven category in software engineering. Um, and then when you have multiple such custom integrations across many agents, you find that you run the risk of having credentials scattered all over the place, which is quite a bit of security risk. Thirdly, agents are not. It's not so easy for them to share resources and information, except if they adopt common standards, just similar to the early days of computer networking, where each manufacturer had built based on their own standards, and resource sharing, information sharing was not so easy, which led to the development of standards like the OSI reference model and then the TCP/IP that is most commonly used today. So now we'll look at the protocols that AI agents use for interconnection. Just a moment, please. Okay, sorry for that interruption. So we're going to look at four protocols. Those are not the only protocols, but we'll just use those four to illustrate how to interconnect AI agents. And the protocols we look at are Model Context Protocol, MCP, which is quite a popular one. The MCP is typically used for connecting data and tools to agents, well, to LLMs, granting LLMs easy access, or how would I say, streamlining access of models to tools and data. The next other one we'll look at will be the Agent Communication Protocol, ACP, which it handles inter-agent messaging. It provides a set of standards for communication between AI agents. And then there is agent-to-agent protocol, A2A, which handles inter-agent negotiation logic. And the final one we'll look at will be the Agent Network Protocol, ANP, which focuses on well, it provides like an AI agent marketplace or network, whichever one call it is fine. So now we'll look at these protocols in a little. We'll take a little bit of dive, well, not a deep dive. It's just an overview. Dive a little bit into these four protocols. Starting with MCP. MCP was developed by Anthropic, and it's a universal standard for connecting AI models with tools and data sources. It allows them to share tools and data via um, how will I say, it standardizes via its standard interfaces. I think that's the right term. It's the beauty of MCP is that it couples the model from the data source. Oh, that's supposed to be from, not for. Couples the model from the data source. So your model can change, your data source can change, and you can change independent of each other, so long as that MCP um, interface, that interface provided by MCP, that interface between the model and the data source, so long as that standard is adhered to. The change in either the tool or the data source does not affect the model, and vice versa. MCP, it reduces the burden of context engineering because it provides structured context. There's already a structure, there's already a standard, so you don't need to go through the stress of trying to do custom context engineering for your use case. The MCP follows a client server architecture. So you have an MCP server and you have MCP clients that connect to that server and make use of the resources available on that server. And it can be used to connect your agents to, say, local files, to cloud resources like Google Drive, Slack, or any other tool or platform that is compliant with the MCP protocol. It can do that simultaneously using just one. Can connect your agents to multiple such tools or data sources simultaneously with just one standard interface. So once your agent or tool adheres to the MCP interface, you can connect easily. So the major thing here is standardization and ease of reuse and ease of sharing. Any questions? Kenneth, please go ahead.
Okay, sir. So if I get what you are saying, the the main goal of the MCP is to connect our agents to external resources. Is that correct, sir?
It's very correct. It standardizes, it provides a standardized way for agents to gain access to external resources, external tools, external data sources.
Yeah, thank you, sir.
Okay, Larawa, you also raised your hand? Please go
Yes, sir.
ahead.
Yes, sir. I want to ask the connection of the AI models to data sources and tools. That's what my question revolve around. Two questions, my one. Do we mean AI agents or do we mean model as an LLM being connected to tools that make the agents? And secondly, and I think that question may answer my question. I mean, the answer may answer the next, but let me just ask the question. I'm wondering what kind of data are we talking about since we are not doing training for models or something. So, I mean, do we mean AI model or AI agents in this place? And if it's model, do we mean the normal LLMs?
Either one fits in. either one fits in. In the tasks we've been doing in the course of this training, we have been building agents that will retrieve data from the internet or from some from some internal external database and so on. That is data. For real world use cases, your applications will use data. Data is not only for training. When we're talking about agentic AI now, we're really not looking at training a model from scratch. We're looking at using an already trained model for solving real world problems. So the data in this case is not training data. The data in this case is data that you use to solve a problem. If somebody asks you, what's the current exchange rate between the US dollar and the euro? How do you find it? There are APIs that provide that. And so if you build that capability into your agent, the agent can autonomously infer that it needs to that this information that the user is asking for is real-time information, well, near real time anyway. And that depending on if it's aware that there's a tool that's provided to it, you can call that tool and retrieve the information and then provide that information to the user. Now, technically, MCP allows models, essentially LLMs, to connect to tools and data sources via a standardized interface. But then, considering too that the models are the reasoning cores of agents, so we might as well say agents. Your agent has one or more models in it, and so if the one model can connect to a tool, then the agent that um, that model is used in that contains that model can also access those tools. I don't know, does that answer your question adequately, or what?
Yes, I do. So I actually asked us because in the diagram on the right hand side, in that diagram, I already saw knowledge base databases and also saw RAG there. So that's why I was wondering if that imputes data different from user query. Maybe it has some other input. But I understand what I've said now, sir. Maybe like website and the likes. Thank you, sir.
Yeah, even RAG essentially is retrieving information from knowledge bases. It could be the internet, it could be a database, it could be some API. Essentially, just you retrieve that information. Those are information that are probably not part of your model's training data. So it's not has not been baked into the model weights. So it allows the model to ground its context based on that information, so that it can provide responses that are more helpful and minimizes hallucination. So it's not about training, like I said. Yeah, we've seen in the previous weeks, we've seen try to build some RAG and agentic retrieval um, agents, but a lot of this we've built these using custom implementations, right? But you could achieve that same thing using MCP. Let's say somebody has already built this tool that can provide some of the capabilities that we built. We built custom implementations for, and the person say already has an MCP server. All you need is to connect to that MCP server if the person provided that such permission, and then you use it. So you just use MCP and you already um, make use of that capability that somebody has already provided, instead of building your own, except where your use case requires that you specifically build your own custom implementation, even if there are other good implementations already available. Okay, so we move ahead. So we'll now talk about MCP. Okay, Kenneth, you want to ask a question? Please go ahead.
Yes, please. So I was like wondering, this MCP service that you are talking about, is it going to now does it has a feature that it authenticates it maybe like takes like your details maybe as we are maybe like signing onto like a website so that like it is like a little bit secured. That is my question because if everyone like can connect to it without no security, so like that's like my question, like just based on security, sir.
Well, just in the same way that you can build an unsecured API or a secured one, you can also do the same thing with MCP. If So it really depends on how the person the specific implementation of that particular MCP server. Okay, so we move to ACP. ACP was originally developed by IBM Research. It is REST based, so essentially it uses HTTP. Um, the main focus of ACP is the technical messaging layer between agents. So it enables the tracking of conversation flow between among agents, and it ensures that messaging in swarms of AI agents provides for reliable messaging amongst the multiple AI agents. So the primary focus of ACP, like I mentioned, is to allow communication, to allow agents to communicate with each other, standardize the communication, and provide for reliability in that communication. So things like when um, a message um, sent from one agent to another fails, there's an error in message delivery. Well, how is that handled? ACP handles provides mechanisms for handling such scenarios. Um, it standardizes the format, the messaging format between agents, and includes metadata like what's the intent, like Trace ID. That Trace ID allows you to know the originator of um, that specific message or that conversion um, trace. Will it be trace? Um, yeah, that conversion chain, its origin, and the sender ID. Who sent that? What? How? Where? How? As in the trajectory. Well, don't misunderstand trajectory here with execution trajectory. The trajectory that message, that conversation involving that message has gone through. So it includes such metadata, which allows for you to manage message exchange between multiple agents. And just like MCP, ACP also uses a client server architecture. So you have an ACP client and an ACP server. And ACP provides for agent discovery. It allows agents to communicate with each other and to collaborate with each other, even when they are built based on different frameworks. Let's say one agent is built with Llama Index, the other one is built with LangChain, LangGraph. With ACP, they cannot communicate with each other without issues, without issues that really would arise from implementation differences. So essentially, ACP standardizes the communication channels and mechanisms between agents. Any question?
Sorry, sir. I'm just trying to ask. I don't know this last bullet point about, and in fact, the whole thing, like just like you said, the last thing you made. This, I mean, not this. I mean, notwithstanding the frameworks with which a particular agent was built, it can communicate with other agents based on that frameworks. But my question, sir, is I'm just trying to imagine what could facilitate such a need for agents to communicate. And I guess you don't mean in an executive system where we have sub-agents now. Or do you mean a different agents for different tasks could be linked together from different purposes or from different people? That's what I'm trying to say.
Okay. Let me ask you a question. What's the latest, let's say, fad concerning agents? There has
Sir?
been what's the latest fad? What's the latest development concerning agents? There has been something that has been making the waves recently.
Okay,
Um,
about
cl-
Claude Quota.
not cloud code,
Okay, about
Moltbot.
sir?
There was Moltbot, Cloudbot.
Okay, okay.
You know about that?
No, sir.
You need to follow up what's happening in there. In agents, there's this autonomous agent that people have been given access to their systems and is able to run autonomously, perform tasks and all that. Just well, it has been renamed to OpenClaw. Just try to read about OpenClaw. Just try to Google OpenClaw and read about that. Maybe after that,
Okay, Oppo
um,
Claw. Claw as in
OpenClaw. Yeah,
CLAW.
yeah, OpenClaw.
All right, sir.
I mean, the autonomy of agent. The idea is that your agent is autonomous, right? You have your agent. I have my agent. Your agent undertakes tasks on your behalf autonomously or semi-autonomously, as the case may be. Your agent does that. My own agent does that. Say I have a business, I sell a service, and I have my sales agent. You have a business, you also have whatever agent. Now your agent infers that you need this service. It searches for who can provide that service. My agent, I provide this service, my agent markets it. Your agent and my agent can work together, negotiate, agree, and your agent could um, recruit, hire my own agents to provide that service to you, and I get paid. You pay me, and I provide the service to you. But really, in actual fact, it's my agent and your agent that do that. So for agents to really collaboration, communication, it can make agents more useful, right? Of course, there are risks. Of course, there are downsides or possible downsides to it. So the idea of these protocols is to enable agents to communicate with each other, collaborate with each other. Um, Earlier, we had talked about multi-agent systems where um, instead of just having nodes in one agent, you have agents working together. We talked about where you have, let's say, you have a coding agent, you have a writer. I think when we were talking about evaluation, or was it ethics and fairness, where we talked about recruiting agents that was trying to um, recruit agents for a particular task, where you have a writer agent, a researcher agent, and so on, a coding agent, right? For all those agents to work collaboratively, they need to communicate with each other. They need to work together. They need to share resources together. But without standards, it becomes difficult. It means that for each use case, you need to build custom integrations, custom tools, right? These protocols standardize those so that it enables you to reuse available resources instead of having to build custom tools, custom integrations for each use case. Does that answer your question, Olanawaji?
It does, sir. So I'm thinking that it seems like there's a store now, maybe like a Play Store where people put resources together of agents that are developed so that people can access it. Is that true, sir?
Yes and no. The point I was making is this. The essence of you having an agent is for you to automate tasks that don't really require human human how do I say human action to free you to focus on things essentially to enable you to scale yourself in the sense that you can achieve more things and to free you to focus on things that really, really require human attention. There are things that can be automated. Now, most times when you apply for a job on whatever, you find an agent would screen your application and maybe shortlist you or so, but typically at some point you have to meet a human interviewer. But by that time you get to a human interviewer, the pool of applicants has been scaled down a lot. I mean, let's say 10,000 people apply for that job. Without agents, it means one person has to, or some people, you want to have to screen all those applications. But now agents help to pre-screen and narrow them down to a number that a human being can now handle without so much fatigue. So essentially, the purpose of agents is to allow you to automate many of your tasks, to allow you to do more in less time or with fewer resources. For example, if more things can be automated, you may not need so many people in a team to handle those. Also, your agent can be working while you're sleeping to handle some of your tasks. You find customer service chatbots, customer service bots that um, when the user has a customer service interaction, today most often your first the first your first interface, first person in quotes that you get to speak with is a bot, and that bot would mostly answer your questions and all that, unless it gets to a point where that is beyond it, and then probably you can either schedule well the human in the loop can come in, can link you to a human agent or so on. And really, if let's say I have an agent for helping me with my task, you have an agent for helping you with your tasks. If your agent must interact with me, a human, and my agent must interact with you, a human, that also limits that skill that we are trying to achieve with agents. I mean, I have an agent that's supposed to carry out actions autonomously on my behalf. You have an agent that's supposed to carry out tasks autonomously on your behalf. And then you and I, we have some transaction we need to do. Why can't our agents handle that on our behalf? Of course, the assumption is that the agents are fully trustworthy and everything. Like I said, there are downsides and risks to all of that. So communication and resource sharing is the primary objective of these protocols.
All right. Thank you very much, sir.
You're welcome. Okay, so now we'll talk about the A2A, agent-to-agent protocol. A2A was developed by Google, and it allows agents, still agents built with different frameworks to interact and exchange information and to coordinate their actions. Well, coordinating their action is essentially it's about collaboration. So they communicate, they interact, they exchange information, and they collaborate. It uses common web standards like SSE, HTTP and JSON, RPC, and it enables mutual authentication between the agents. It allows agents to discover each other's capabilities, and it allows an agents to delegate tasks to other agents. And it uses the master worker architecture where you have one master agent that manages multiple worker agents. Does anyone have any question on this? Note that what we are doing here is an overview. We're not doing any deep dive, but I would encourage you to try to read about these and try to look at the specifics, try to um, see how you can integrate them little by little in your projects. And yeah, I mean, you could find them quite useful, and they would be helpful in the agents that you eventually build. Okay, Kenneth, you have a question. Please go ahead.
Okay, so I have my two questions, but the first one is based on the previous one. I'm sorry to take you guys back. So I was like wondering, is the ACP related to let's say you have your agent that you have built, and I have two agents that I have also built. Is it related to me being able to like communicate with my agent, or it is specifically with external communication? And that's the first one. I don't, and the second one, I don't know. So, will you answer the first one, or like I should ask the second one?
Whichever one you prefer, I can answer that one. And okay, let me answer the first one. It's a simple thing. It's for agent to agent communication. It's not for human to agent communication. It's agent to agent communication. And whether those agents were built by the same person, whether those agents act on behalf of the same person or different people, it doesn't matter. It is for communication between agents.
Okay, now well noted. And the final one will be the agent to agent. Is there a way that these agents can substitute each other's tasks? Because I see some like similarities between agents to agents and the previous one, which is agent communication protocol.
Of course, there is some intersection between all these protocols. You know, agentic AI is well, it's I was about to say it's an emergent area, but I mean there have been agents since, but it blew up just recently, so it's developing. It's in a state of flux, right? First of all, these protocols have are attempts at standardization, and it's possible that in the future some of these could also um, there could be some integration between these protocols. It's just important to be aware of them to try to use them well if your use case requires, or if they are relevant to your use case, or if they are required for whatever project you're doing. But I believe that there will be changes in the future. Um, I mean, just as um, the internet and networked communication and software engineering and everything everything we take for granted used not to be that way. Earlier on, equipment from different manufacturers could not talk with each other. Different manufacturers' equipment could not share resources together until communication was standards were developed. I mentioned the OSI reference model, and then there's a TCP IP that is mostly used for. I mean, even the this class we are having, we are using TCP IP for the network communication. So that is what is happening in the field of agentic AI today. Before MCP, I mean, you had to build a new integration for each custom tool you were adding, for each custom skill that you were adding to your AI agent. But with MCP, once there is an MCP server for that specific tool, you just need to make use of that server. You just connect to it and make use of its capabilities. MCP allows MCP servers would expose tools, data sources. So, for example, you want to connect your agent to Slack. There's already an MCP server for Slack. Why build a custom integration for Slack when you could just make use of that existing Slack MCP server? That's actually the benefit that the kind of benefit that these protocols provide: ability to reuse, standardization, and breaking down that integration wall that I talked about at the beginning of today's session. Does that answer your question, Kenneth?
Yes, please. Appreciate it.
All right, you're welcome. So we go to the next one, and that's the agent network protocol. Agent network protocol, it was the idea of Chang and a few others who authored a technical white paper about it. The idea is really about providing a decentralized registry for indexing AI agents, which facilitates searching for AI agents. I think I talked about it being like providing an AI agent marketplace. So when you have an indexed registry, well, decentralized in this case, perhaps using blockchain. Um, so that makes it easy to search for agents for any particular use case. Let's say I need an agent that can what would be the use case now? I need an agent that can help me book flights or book cheap flights reliably. I mean, that's just what you need. You can give your agent that requirement, and your agent can search on that registry, and it's able to find an agent that can provide that capability that you need, and you can go ahead to engage that agent to provide that service that you want. I mean, the idea here is decentralization, perhaps using a distributed hash table or a blockchain. Now, ANP, it governs how agents can find each other across a mesh, a distributed network. That's essentially what I described earlier. And it facilitates collaboration among billions of agents. If they are indexed on this decentralized registry, it's easy to find an agent that has some required capabilities. And with ANP, you can verify that agent's legitimacy, and the index would provide you with a history of that agent's task completion history so that you can know, hey, does this agent that I've been able to get from my search for a given skill set or capability, does it have a history of completing tasks successfully? If not, then you know that that may not be a reliable agent. But if it has a history of completing tasks successfully, then based on that, it provides some level of trust, anyway, some level of verification um, of the agents that are indexed um, on the registry. And then it also handles micropayment between the agents. So your agents can autonomously engage other agents for certain services, and they can negotiate payment for those services rendered. So essentially, it improves that autonomy, allowing the agents to even do more on your behalf with the added benefit of verification and confirmation through the decentralized registry. Of course, the architecture is decentralized peer-to-peer because it uses a peer-to-peer system and it's all decentralized, just like blockchain. Any question? That's actually the last of the protocols that we had to talk about today. So does anyone have any question?
Sorry, sir. I know you mentioned earlier on when I asked if there was, if there is any kind of maybe Play Store, but you say yes and no, and I've seen you mention Marketplace like 2 or 3 times now. Like when people build agents, they don't build there like Google Play Store. So whoever needs to go there and download it, and can like we see reviews on a Google Play Store, like people giving their review 4 star, 3 star. You mentioned that people who have a history based on reliability. So where is this marketplace?
I just talked about ANP as a protocol that provides a centralized registry and that it allows for verification of agents' reliability and its history of task completion. Does that not sound like what you just talking about there?
Yes, sir. Does it mean
Like a
that
place to
AMP hosts all these agents and MCP hosts his own separately, or are they only standards, or there's a database where one can just visit and access the agents?
AMP is a protocol. You
Okay.
can build an application or a service to implement that protocol. A protocol is just a set of rules that guides
Yes, sir.
collaboration, that guides
Yes, sir.
communication.
That is the PIP.
So,
Yes, sir.
yeah, these are protocols. They are not implementations, they are protocols.
Okay. How about the marketplace you mentioned, sir?
But that's just what I talked about. AMP is a protocol that facilitates that. And implementation is a different thing. So you could build one,
Okay.
but also you should know that these are evolving protocols too.
Yes, sir. Thank you, sir.
Does anyone else have a question you want? Come. Okay. And if there's no other question, I'll stop the recording because that's essentially the class for today, and then we'll discuss a few other things. Because like I mentioned at the beginning, this is the